Hi everyone and welcome to my YouTube channel. So in this video we'll be solving a problem from the IMO shortlist 2011 A3. So this problem, because it is A3, it is classified as medium. And in this problem we'll be solving a functional equation with two functions f and g. So instead of solving it with one function f, we have two functions f and g. Okay, great. So before we get started, I just would like to announce that I want to start a new course, a geometry course, but I think I will give the lessons using a tablet because it's hard for me to draw diagrams on this whiteboard because it's small, and unfortunately I'm actually new to using tablets, so if you have some nice ideas, please tell me in the comments. And now let's get started. Okay, so we need to find all functions f and g from R to R such that we have the following functional equation. G of f of x plus y is equal to f of x plus 2x plus y times gy. Okay, so let's take a look at our functional equation. We have here g of f, and here we have f, and here we have g. Here we have a simple f, and here we have a simple g, and here we have a g of f. Okay, so let's actually begin by the simplest thing in the world, which is substituting with 0, right? Okay, so let's first of all try substituting y with 0 and x with 0 and find out what are the relations that we are going to get. Because we can then evaluate g of f in two ways, right? Because we will have g of f of x and g of f of y, and we can calculate this using f and g. Okay, so let's do this actually. So first of all, let's substitute p, 0, and y. Okay, so actually here I want to tell you some a nice trick that I use. I often like to deal with only one variable x. So instead of substituting p0y and then then we're going to substitute px0, I like to substitute p0x. So then I have only one variable, which is x. So like I like representing all my relations using only one variable x. This way I can easily compare my relations. So let's actually substitute instead of y p0x. Of course you don't have to, but it would be nicer. So p0x. Okay, but I need to pay attention now, because now each x is 0. So this is g of f of y, but because we've substituted y with x, this is going to become g f x. Okay, x is equal to f of 0 plus this will become 0 and this will become x, x gx, x times gx. Okay, great. So we have this relation now. So actually let's assume that c is equal to f0. So now we can write this as g of f of x is equal to simply c plus x times gx. Great, so this is the first relation that we have. So actually, how can we read this relation? We can read it as we know now the value of g of f using g. Okay, so that what is the first relation. Okay, what about the second substitution? Now we will substitute px0, and let's find out. Now we will have g of f of x also. So as you see, Now here we have g of f of x, and here we have g of f of x. So that is why I told you I substituted x. If I didn't substitute x, this will be g of f of y. But again, it's no problem because you can then substitute y with x, no problem. Okay, so now we have g of f of x, and now this is f of x plus 2x times g0. Again, let's assume that a is equal to g0. So let's make these assumptions. And now we can write this as g of f of x is equal to f of x plus 2ax. So this is the second relation that we have now. So let's give it a number 2. Okay, so what now? We've substituted a very simple substitution, p0x and px0. Okay, so now, as you can see here, we have g of f of x, and here we have g of f of x. So we've calculated this in two ways. So that means that we can compare this with this, right? Because the left-hand side is equal, that means that the right-hand side is equal. So from 1 and 2, we get the following now. So using 1 and 2, we now have the following nice new functional equation. C plus x times g of x is equal to f of x plus 2 times a times x. So what does this mean? Actually, this means a lot, because take a look here. What are the variables? It is f of x and g of x, right? Those are the functions. So now actually we don't have two functions anymore. What does that mean? We don't have f and g. Now actually I can find the value of f using g. So if you gave me, for example, g of x is equal to 0, then this will be known. I can calculate f. If you told me g of x is x, then I can calculate f of x. It will be c plus x squared minus 2 times alpha times x, right? 2 times a times x. So this actually means that we have calculated the value of what? Of f. Great. So this will be f of x now is equal to what? To x g of x plus c minus 2 times a times x. Great. So now actually we have only one function instead of two functions. And this is a very nice technique when solving a functional equation with two functions. If you can calculate one function using the other function, then simply you only have one function. This is a functional equation with one function f, which is easy now to handle. Great. So actually, let me erase this and keep just this nice result. Okay. Okay, so now I want you to think, what next? What can I do next to solve this new functional equation, or this functional equation with only one function? And just to remember, we need to write those. C is equal to f of 0 and a is equal to g of 0. Okay, so now I have this. So what next? So let's take a look at our original functional equation. Take a look at the left-hand side. This seems familiar, right? G of f of x plus y. X plus y has a nice property that we've discussed in one of the previous problems. X plus y is symmetric, right? Because x plus y is equal to y plus x. So what can I use here? Exactly, I can use the symmetry substitution, right? So now I can actually use pyx and compare it with pxy. Great, so now let's actually write pyx. Pyx. Because the left-hand side will be equal, will be the same. So again, we have g of f of x plus y. But the right-hand side is now f of y plus 2 times y plus x times g of x. Great. So again now, I have two equations. The left hand side is the same. That means that the right hand side is also the same. So again, the same idea. So now we have this actually is equal to this, right? Great. But remember that we know the value of f. So actually, now I can substitute f of y with this and f of x with this, using this. So actually now I have only one functional equation with only g. So I have g of x, and that is linked to g of y. So actually, our problem is nearly done. So we just need to write some substitutions and do some calculations. So actually now, let's again give this number. So this is 1 and this is 2, and from 1 and 2 I have now, and actually let's use this immediately. So using 3 as well. Now we have f of x plus 2 times x plus y times g of y is equal to this, right? Because the right hand side is the same. But let's immediately substitute f of x with its value that we've calculated here. So now we have x gx plus c minus 2ax plus this 2x plus y times g of y. This is equal to what? To this right here. F of y is now what? From here, it is y times g of y plus c minus 2ay. So we need to pay attention here. Plus this here, plus 2y plus x times g of x. Great. So now I have this very, very simple functional equation with only one function g. So I can actually solve this very easily. So let's actually cancel the common terms. So here we have c, here we have c. Okay, here we have y times g of y, and here we have x times g of x. Here we have 2x gy, and here we have okay, great. So actually here I have y gy, and here I have y gy, and here I have x gx, and here I have x gx. Okay, so that is great. So now actually I can even more cancel this 2. I can divide by 2, and now I simply have the following very nice and easy functional equation. It is simply, I can take actually x as a common factor, and this will be x g of y minus a is equal to, again I can take y as a common factor from the right hand side, and this will be g of x minus a. Great. So now I have this simple functional equation. And of course we are done, because we can simply substitute y with 1 to get the value of our function. So simply by substituting y with 1, we get that g of x is equal to, this becomes 1, so this is g of x minus a, so I can take it to the left hand side, and this will be x times g of 1 minus a plus a. So actually g is linear, because g is equal to some number, some constant, times x plus a, right? So I can actually write this as bx plus a, and of course this is b. This is b. Great, so now I know the value of g. So I know the value of f using this. So what is the value of f? Actually, let's erase this here to have some space. so we are nearly done. Okay, so now we have calculated the value of g. Let's write it down. G of x is equal to b times x plus a for some constant p, which is this g of 1 minus a. And we know that f of x is equal to this. So let's calculate f. F of x is equal to, okay, so we need to take x and multiply this by x. So it is actually bx squared plus ab plus ax plus ax plus ax minus 2ax. This will become minus ax and plus c, of course. So yes, we are done because we found it. We found the value of g and the value of f. Okay, so what next? So now actually we need to simply evaluate the value of b, a, and c and find out what are the constants a, b, and c. And this is very simple. You can actually substitute in the original functional equation to get the value of a, b, and c, or actually you can substitute in one of the equations that we have found earlier. So I'm going to substitute with the functional equation that we found earlier. I think it was when we substituted p0x. P0x will give us, let's write it down, it was g f of x is equal to f of 0, which is c, plus y times g of y. Okay, so I'm going to be using this to get the values of a, b, and c. So let's evaluate g of f of x. Now f of x is this, and g, to get g, we just need to multiply this by b and then add a. So let's multiply this by b. So to multiply this by b, we will get b squared x squared minus abx plus cb. And now we just need to add a. This is the left-hand side, g of f of x. This is equal to c plus y gy. Gy is this. So I just need to multiply y by this. To multiply y by this, I think I made a mistake. Okay, no problem. This is simply not y gy, but it's x gx, right? Because we did a substitution p0x, so we don't have any y. So it is x gx, which means that this is c plus x times this bx squared plus ax. Okay, so now I have this very easy equation. Okay, actually it is a polynomial equation. So actually we can now compare, we can take each term, each power of x. For example, we can group this as the following: b squared minus b times x squared. What about x, the coefficients of x? This is minus, and this will be minus, so it will be actually ab plus a times x, and this will be cb plus a minus c is equal to 0. Okay, great. So if you don't know, actually, here we can immediately conclude that this is 0, this is 0, and this is 0. Because we have a polynomial. If I told you that a polynomial is equal to 0, then that means that all the terms are equal to 0. All the coefficients of x, x to 0, x to the 0 power, x squared, x cubed, and all the coefficients of the powers of x are all equal to 0. So actually now I have three equations, which are b times b minus 1 is equal to 0. And the next is a times b plus 1 is equal to 0. And also we have this one, cb plus a minus c is equal to 0. So I just need to solve these three equations to get the values. Of course, from the first equation, I have two cases. Either b is 0 or b is 1. So let's actually erase this and solve this simple three equations. Okay, we will need this. We don't need this anymore. So we have two cases. Case 1 is b is equal to 0. Okay, in this case, b is equal to 0. So that means that a is equal to 0 as well. So that means that a is equal to 0. And that means that this is 0 and this is 0. So that means also c is equal to 0. Okay, so what now? The value of g is 0 and the value of f is 0. So that means that f of x is equal to g of x and it's equal to 0. So we need to check, does this solution work? So actually yes, because 0 is equal to 0 plus 0. So it works. So this is the first solution. Great. So what is the second case? The second case, case 2, is b is equal to 1. So that means that a is equal to 0. A is equal to 0. And a is equal to 0. B is equal to 1. That means that c minus c is 0, which is always true. So c is just any real number. We don't have a condition on c. So now, actually, let's evaluate the function f and g. So now we know that g of x is equal to b times x plus a, which means that it is x actually. Okay, what about f? F of x is equal to, b is now 1, so it is x squared, and a is 0, so this is 0, so it is x squared plus c. So now simply I have these two functions. G of x is equal to x, and f of x is equal to x squared plus c. And actually you can check that these two solutions work by simply substituting them in this functional equation. So g of f of x plus y is simply f of x plus y. You can check that f of x plus y is equal to f of x plus 2 times x plus y times y. And this is true for any c. So actually our solutions are this one and this one. And of course here we don't have any pointwise trap. Because why we don't have a pointwise trap? Well, because we have two separate cases. So we have case 1, b is equal to 0, and case 2, b is equal to 1. So the solutions are from separate cases. So here we don't have any pointwise trap. If you are wondering why we didn't discuss the pointwise trap. So simply we have no pointwise trap here. And yes, that's it. We are done. So let's discuss what we did here. So first of all, we found this functional equation. We took a look at it and we realized that we can simply substitute x with 0 and then y with 0 to get g of f of x calculated twice in two ways. This way I can find the value of f using g. So now I don't have two functions, I have only one function, g, because I can calculate f using g. Next step is to realize that the left hand side is symmetric. So I can apply the symmetry substitution and get a single equation with one function, and it is very easy to solve by simply substituting y with 1, and we immediately got the value. We got the solutions using a, b, and c. Then we just substituted in the original functional equation to get the values of a, b, and c. So that is the moral of the story here. Okay, so in the next video, in the next lessons, we'll start with a new topic actually, with a new technique, which is Cauchy functional equations. So we'll discuss Cauchy functional equations and see their applications in Math Olympiad. So if you guys like this video, like, share, and subscribe to the channel, and see you guys in the next video.